Hey everybody, this is Mrs. Dinkelman, and these are the notes for Lesson 1.1, Limits and Continuity. This is for when I'm gone on August 31st, 2023. And we're going to do about half of the notes, although I'm going to pause you in the middle or recommend that you pause and move along. But we'll finish up notes on the Friday when I get back, and obviously any questions you have, we will do that. And I'm going to erase this now because I recorded this and then realized it was totally recording the wrong screen. So I'm doing take 2 here. So I will erase those. Sorry about that. Okay, let's just go ahead and why don't you go ahead and do those function values. I'm going to do those real fast. If you want to speed me up, obviously that's okay there. So that's something we're familiar with. We just want to know what the y-coordinate is at -4, the y-coordinate at -1, the y-coordinate at 2 looks like it doesn't exist because there's nothing there. The y-coordinate at 3 also doesn't exist, kind of for a different reason. And then at 5, the y-coordinate is 2. Now, these limit statements over here are really especially for graphs that, I have a lot of marks here, graphs where there's a lot going on and there's some breaks in the graph, and we still want to be able to communicate that something different is happening with the branches or like the curve as opposed to exactly what's happening at like the function value, the y-coordinate. So the way that mathematicians write that language is by using a limit. So the limit is a y value, but it's really the y value that we're approaching. So let's talk about some of these and hopefully that will maybe sink in. So this is saying that the x is -4. So we're going to look at x is -4. Now there's nothing weird happening here at -4. So the answer to our limit is literally just the y-coordinate because it's a y value. Different story when x is -1. So let's look here at -1. So this is where our first kind of break in the graph is. So we know that the y-coordinate is 1. But what the limit wants to describe is what are the branches look like they're doing, or where does it look like it's approaching? I like to think of this sort of like hunters that are like Elmer Fudd heading toward the rabbit holes, right? So the hunter from this side is heading toward that hole. Hunter from this side is heading toward that hole, even though the rabbit is not there. So the hole that they're heading toward is the answer to the limit, and that looks like that was the y-coordinate 4. Let's look at what's happening at 2. Similar idea. So this hunter is heading this direction. This hunter is also heading toward that same hole, but there just is no rabbit at all anywhere near. But the hole they're heading toward is the y-coordinate. How about 1? Okay, on 3, you're going to have to make a decision what kind of mathematician you are. And what I like to do for 3 is to describe what the asymptote is doing. So if we think about hunters again, it looks like they're basically heading down toward -infinity. But some mathematicians don't like that because if you look up here at the definition, it says it's a y value. Well, infinity is not a value. So some mathematicians like to put does not exist. AP doesn't care which one you pick. You just need to decide what kind of mathematician you are. Okay, at 5, something strange is happening, which is why you can see they're going to ask us some more questions about 5 in a second. So this hunter is heading toward this hole. This hunter is heading toward this one. And since they're heading toward different holes, that means that the limit does not exist because there's not one y-coordinate that they're heading toward. I'll talk to you a little bit tomorrow about, I kind of call it the drunk test. And I don't know if my webcam shows up or not, but I'm going to pretend like it does. If not, you can ignore me. So I think of this like a drunk test, like you need both fingers to touch your nose. And in this case at 5, it doesn't happen. So it's kind of like you're touching your nose and your chin. So you would fail the drunk test, which means in this case, our limit does not exist. But we can do one-sided limits because clearly at this spot, we have something different happening on the left branch versus the right branch. And so we want to communicate that perhaps as well. So this little negative up here by the 5 tells me that I'm coming from the left-hand side because if you think number line, negatives are on the left-hand side. So we're coming from the left hand. So the left-hand branch looks like it's heading toward the y-coordinate -1. While the right-hand branch, see that little plus sign up there, the right-hand branch looks like it's the y-coordinate 2. This hunter just happens to be going to the right hole. This one is definitely not. Now, it's okay if this doesn't sink in right away. Limits are always kind of tricky for people, and it really is a brand new concept. So if it's not sinking in, just kind of give yourself a little bit of grace. What I would like you to do right now is pause the video and do 1 through 15, and then come back to the video and listen to more notes. So if you see 1 through 15 in your assignment, it's very similar to those questions that we just went over. It's just a slightly different graph, but it does have the breaks and stuff in it, just like the previous one. So hit pause, do 1 through 15, and then come back. Okay, the second half of today's notes is about continuity. So if you look, this is a really good definition for continuity, although it's not formal. It's just that if you could draw a graph without picking up your pencil, then we know it's continuous. This graph up here definitely would have to pick up my pencil at several locations to be able to draw it. So that's what this is going to talk about. Now this right here in my box here is the formal definition for continuity. So I would recommend highlighting, starring, boxing, something, because this is, when we have to justify continuity on the AP exam, this is the language or the symbols that we have to use to justify it. So I'm going to kind of jump down here. I'm going to talk about example 13 as we go through here. And I'm going to think back to this limit idea. So I'm going to start backwards here and look at this first break. So this right here is basically saying that the left branch has to equal the right branch, has to equal the function. So this first one at x is 5 definitely does not pass the continuity test because the left branch doesn't even equal the right branch. So that breaks down here. So there's definitely a discontinuity at 5. Okay. There is a discontinuity at 3. Maybe the left branch equals the right branch. They're both heading down toward negative infinity, but the function doesn't even exist at 3. So it fails by that third part of that equation. So 3, definitely a problem. At 2, the left branch equals the right branch, but the function doesn't even exist. So that fails by that third one as well. At -1, the left branch equals the right branch, but the function is different, so that fails. And Gary just happened to pick this point. We could pick a lot of points along this graph that actually pass the continuity test, and doesn't even have to be whole or an integer values. But at -4, the left branch and the right branch are good, and the function's actually equal there. Same with the one I just put there at -5. Left branch equals right branch, and the function actually is there. And that's most of our graphs, but not all. The last thing for today is Gary likes to talk about the difference between removable and non-removable. We will eventually be able to see those algebraically as well. But think of removable as the holes in the graph, and the non-removable as being either the jumps or the asymptotes. So if we look back up here at the discontinuities, let's go backwards again. Example 14, by the way, is asking which ones are removable. So at 5, I would consider this a jump. It just jumps. Let me move that down a little bit, sorry. It just jumps from one branch to the other. That's a jump. Obviously at 3, we have an asymptote. 2, that's a hole, okay? We just literally took a piece of that graph out. We didn't make it jump from one to the other. We just took a piece out. So that's why I have 2 listed as a removable. And then also at -1, that one was removable. We actually removed it and put it somewhere else, but that's still considered removable or a hole in the graph. So that's all the information for today. We are going to move along to the notes tomorrow, just showing you. Yes, I have day 2 on there. That's what we're going to do. My recommendation today is that you just do that first half, the 1 through 21. And I'm going to flip over to show you where that ends. So a lot of graphs on this second page, similar to what we saw looking at the graphs, and then stop at 21. Again, tomorrow when I come, the first thing I will do is see if you have any questions, and I'm happy to go over a million questions. I know there won't be that many, but we'll get all those questions answered first before we move along to day 2.